Oh, and there's so many. I got it.
Yeah, it was a very intelligent joke. So write a piecewise function for each of the following. So the first step in writing a piecewise function is to identify the different components that you're working with. So in this case, we have three pieces. We got, and in each case they're lines, they're all linear functions, but we'd have to write the equation passing through each one of those lines. Now one of them is pretty easy, but the others you'd have to do a little bit of legwork. All right. So what we can do, and actually I created, of course I did, I created a calculator that will compute linear equations for you. I could show you that in a minute, but I'll do it the old school way first. So what we need is a slope and a y-intercept. So y equals mx plus b. Or you would use the point slope form, y equals m times x minus x sub 1 plus y sub 1, which is a little bit more user friendly because all it requires is a point and a slope. All right, so if you know a coordinate on the graph, you're good. All right, as long as you can pull the slope from that. All right, the other version, the y equals mx plus b, is good if you know or can easily determine the y-intercept. All right, so what we're going to do is just go through and figure out all the slopes here. In this case, we have a coordinate open circle, but it's still a coordinate of 0, 0. So if I want the slope, I could do it one of two ways. I could just do a quick rise over run, right? A little down 1 over 1 kind of business, or I could use the formula, change in y over change in x. All right. So if I'm just doing the rise over run, I would pull the slope from this by saying I'm going down 1 and to the right 1. So the slope would be negative 1 over 1, which is negative 1. All right. If you're doing it by points, change in y over change in x, we'd have 1 minus 0 over negative 1 minus 0, which is negative 1. All right. The y-intercept is 0, goes through the origin. Even though it's an open circle, it still trends towards the origin, so we can pull the y-intercept from that. All right. So I could say that the equation of this piece is y equals negative 1x plus 0, or just y equals negative x. We'll worry about domains later. All right. For the second piece, it's a horizontal line. Horizontal lines are always in the form, assuming you don't want to do this using a formulaic approach, they're always in the form of y equals some number. That number should be whatever the y value is of that line. All right. So in this case, I would just say y equals 1. All right. But you could also use this technique here because you can pull the slope, which is 0. Horizontal lines have 0 slope, and the y-intercept of a 1, and get it that way. All right. The last one, I'm actually going to use the point slope form because even though I suppose I could figure out what the y-intercept is, it's not going to be the easiest thing in the world when you don't have boxes to count and stuff like that. All right. It's actually not bad. It's not terrible at all, but still, I don't want to bother with it. So I'll figure out my slope, a little rise over run. Now, this is 3 units. This coordinate here is 3 units to the right, so it has coordinates of 3, 0. So my slope, change in y over change in x, 1 minus 0 over 1 minus 3. So that's going to be negative 1/2. Grab one of the points and designate it as x1, y1. All right? So the one that involves nicer numbers is the one I'll go with. 3, 0 looks pretty good because it has a 0 in it. I'm going to call this x1, y1. And then chuck all that information into my point slope form, coming up with y equals negative 1/2 x minus 3 plus 0. Feel free to not write the plus 0 if you don't want to. But this is perfectly fine. There's no requirement that you simplify the equation, so leave it in this form if you want. I mean, I personally would drop the plus 0, but even if you left it there, that would be okay. All right, so now in order to write it as a piecewise, first I'm going to say that this whole thing constitutes f of x. All right, all three pieces together make up the function of x. All right, we have three pieces. Y equals negative x, y equals 1, and y equals all this stuff. All right, we always list our piecewise function based off of the pieces as we move from left to right. All right, so the first piece is negative x. We don't write the y equals because this is the y equals. F of x equals takes on the role of y equals. All right, so f of x equals negative x, but only if the x values are between negative 1 and 0. All right, so you could write your domain either as an inequality or in interval notation. It's up to you. When it comes to piecewise, you have a choice. All right. When it comes to stating domains, you just look at the instructions. It'll either say inequality or interval notation. All right. So most people recognize piecewise functions written in inequality notation, so I'm going to write it that way. So negative 1 less than or equal to x less than a 0. The second piece has a y value of 1. That's only if we're living in the interval going from 0 to 1. All right, the x value of 0, the x value of 1, that's the interval that we're living in. So from 0, open circle, so less than, x less than or equal to 1. Then the last piece, distribute it out if you want, but it's not necessary, negative 1/2 x minus 3. That's going from the x value of 1 to the x value of 3. All right? It's a closed circle on the left, so 1 less than or equal to x less than, open circle on the right, less than 3. All right? And so that would be the piecewise function that represents this graph. Now, there really isn't, any way other than, figuring out the equation of each piece. There isn't another way to come up with the equation of the piecewise function. But I do have a calculator, and I'll post this up on Schoology in a little bit, that will come up with the equations of the lines for you if you tell the calculator, you tell the Desmos calculator what the points are. So I'll just show you that real quick. It's called writing the equation of a line. So, like I said, I'll just walk you through it. Input the two coordinates in the table. So instead of the example that I have here, 2033, I would put in, let's say we're just working off of this first piece here. I'd put in negative 1, 1, negative 1, positive 1. The second coordinate would be 0, 0. All right, and then if you scroll down, I have the point slope form equation. We could also do a slope intercept, but the point slope form equation is usually where we kind of want to live. And you'll find as we go through the course, we're going to almost exclusively work with that form of the linear equation. It just kind of looks weird. It created the graph for you, which is wonderful. You see this command here, this y1 tilde m x1 minus h plus k. That's just kind of like hideous to look at. But it's the same form as the point slope form. Y equals m x minus x1 plus y1, except I'm just using h's and k's instead of the x's and y's, right? So if you just look under parameters, you see what the m, h, and k values ought to be to write your equation, right? So what this translates to, I gave the model here. It'll actually graph the model. If you plug in the given m value, which is a negative 1 for m, the given h value, which is a 1, and the k value, which is negative 1, you'll have your equation. So negative 1, parentheses, x minus 1, plus 1, minus 1. All right. And so that's actually the same equation. I could turn them both off. Actually, turn everything off. Turn them both on. You see that they end up being the same thing. All right. So this calculator will write the equation of a line for you. Now, these problems, they're not difficult to write the equation of a line for, but you still probably don't want to have to do it. All right. There's going to be plenty of instances where the numbers aren't really too nice to look at. So having a calculator that'll do it for you is a really good thing. But then you also kind of look at, all right, well, both A and B here are linear cases. What happens when you're dealing with something that's not linear? We'll get that. We'll cross that bridge when we get to it. But for now, we'll just focus on the linear stuff. All right. So that's all I wanted to talk to you about. Like I said, I'm going to save this up on Schoology for you, but I figured I would go over it at least a little bit. All right. So the rest of the period is yours to continue working.